Hi, welcome to Hacking Humanity with A/B Testing. I have a lot of content to cover here in a small amount of time, so I'm going to try to move through things kind of rapidly. I'm also going to try to speak as slow as possible and still be able to meet that requirement. So I want to start with the premise or the assumption that technologists are not typists. We are solvers of problems. We don't just design and write code, but rather we are tasked with coming up with solutions. And the businesses that we are solving problems for almost all universally have the same problem: revenue growth. They all want to be bigger and better businesses. And we as technologists are asked to build things that will improve the revenue and grow a business. What I'm going to talk about today are the concepts around building and testing software in a way that will do just that. But first, hi. Back home, my wife calls me the house bear, so that's why I picked that. A little bit about me. I am the director of engineering at Just Answer. I've been developing software since the late 90s. I've built things that have generated billions of page views and served millions of paying customers. I try to fancy myself as a team motivator. I spend a lot of time trying to understand businesses, and I kind of consider myself a dirty coder. I like to just get stuff done and get stuff out there and see what the reaction is going to be to it. My first programming language I ever worked in was in 1985, was Logo and Apple IIGS, when I was in elementary school. And the first time I got a paycheck being a professional programmer was in 1999. So one thing to keep in mind is that explaining technology is very hard. If I start to lose anybody today, or you need me to slow down or re-explain something, please let me know. You can put a hand up and I'll know that I need to slow down. Now, here for comedic effect is an example of a guy trying to explain Bitcoin and not succeeding very well.
So basically, there are these things called miners. And so the miners are computers. You plug your computer into the wall socket, and your computer does math. You can't really hold them. They're actually inside the computer on this thing called a blockchain. Blockchain. Block is the things of the miners. Chain is what makes them all into one thing. What part of this doesn't make sense? I'm trying to explain it to you. There's a block, and there's a chain, and there's a computer that mines bitcoins. No, you can't hold them, but it's in the internet of things. It's part of the blockchain, and you can spend it. There's math and computers, and then that makes a coin. Yeah, you can buy things like other cryptocurrencies with it. No, they don't do anything, but that doesn't matter. Can't actually spend it, but I'm just trying to say, if you want to be rich, you can put your money in Bitcoin, and then you'll be rich. It's not that hard. No, I'm not yelling. You're yelling. Just buy it, okay? Where the fuck is our waiter?
So in today's agenda, I'm going to be talking about building, measuring, and learning. So this is how to design and build and run your A/B experiments, and how to actually analyze that data, and how as an organization you can kind of learn from these things and use this information in a meaningful way. This concept of build, measure, learn comes from a book called The Lean Startup, and it's written by a guy named Eric Rice. He believes that using the lean startup approach, companies can basically create order from their chaos and create a testable and accountable way for moving forward. This is the flywheel of the framework for launching software that successfully grows a business. Now, I could easily spend the entire conversation just talking about the lean startup, but I'm actually going to use this as a framework for A/B testing inside of it today. So build, measure, learn. Another way to think about this flywheel is that you have a great idea or improvement on your existing product. So you code and launch your test with the new idea in a new way. That's an A/B test. It permits you to measure the results, and then you analyze the data and learn from that data and make decisions about it. This is the general process that we'll be deep diving into today, and we'll primarily be looking at this measure part. But let's not get ahead of ourselves. Let's start with the basics and let's define what an A/B test is first. So if we think about our old development process, basically you have an idea, your UX person comes up with a mock-up, they maybe come up with another version of that mock-up, and you guys go back and forth trying to come up with the best possible thing that you've thought of. Then maybe somebody does a prototype of that mock-up. Finally it gets to engineering. Engineering starts coding on it, and then it finally ships to the real world. Can anybody tell me what important actor is missing from this process? That's right, it's the customer. The customer is not here. And ultimately, that's who you're building your software for. So as software developers, it's not our job to just build what we're asked, but to solve that business problem. Nothing is more expensive than building the wrong thing, which can be worse than just even sitting still. So let's introduce A/B testing. What is A/B testing? A/B testing splits traffic, some percentage, let's say 50-50, between a control and variation. A/B split testing is a new term from an old technique called controlled experimentation or randomized controlled trial. That's it for the moment. For example, if you ran a simple A/B test, it would be a 50-50 traffic split between the original page and the variation, and customers visiting your website would see or interact with one or the other. Let's pretend that you're a developer working at a company that specializes in selling widgets on your website. Widget sales have not necessarily been bad, but they could be a lot better. And the team you work on is charged with increasing sales by 10%. In this scenario, let's pretend that your company is working like I discussed before in the old way, not really agile. Instead of just changing your site and hoping for the best, instead you would try to code and introduce things as an A/B test. The premise is simple. You create an experiment that splits the traffic, as I mentioned. Users are assigned to a variation and are counted as members of the experiment, and will count how many users reach that goal. A goal is just clicking and continuing to a next step, actually buying your product, or maybe providing an email. It doesn't matter. The premise is the same. You're trying to discover the best performing version and make it that what your users encounter normally. Sounds pretty simple, right? Unfortunately, there's a lot of details that must be tracked. Some of the caveats to think about. First, you need to gather baseline data from an existing version or expectations that you know what you're trying to improve against. You can't improve what you can't measure, right? You also want to show the same versions to the same customer. I mean, think about it. If your customer came to a landing page, saw one experience, wasn't really sure what they wanted to do, left your website, did some other things on the internet, and then came back and saw a new variation and then hit the goal, which version sent them over the edge? Was it the one that they saw first or the ones that they saw second? Also, you need to keep track of the visitor count needed in order to make a decision. So this is determining sample size. Certainly you would make a decision based upon 3 users, but would 100 be enough? How about 1,000 people? We'll discuss about sample size software, or software that'll handle sample size estimation for us later on. But for now, just know it's something that needs to be tracked. And finally, is the difference even big enough? Is 8% really different than 8.1%? So are you declaring something a winner that statistically is so noisy that we don't actually know whether it was a winner or not? This problem gets even more complicated when your A/B test has more than one additional variation. The math could be quite tricky for what we call an ABN test variation. You can also run what are called multivariate tests and multi-armed bandit tests in the place of ABN tests. I'm not going to be diving into these concepts today, but be aware of them, that they can get very complicated at larger scales and different types of testing can be employed. All right, so let's get to the title of today's presentation. Now that we've defined what an A/B test is, in the context of this presentation, I want to pause for a moment and talk about who we're actually going to be designing our tests for. So who are we? That's right, humans. Ultimately, the purpose of the tests we are designing are to elicit human response. In our previous example where you worked at the company making widgets, you needed to increase sales by 10%. What does that actually mean? It means that hypothetical company needed to create new software that would entice some segmentation of humans to buy more often. See, in the A/B testing world, you can scientifically measure winners and losers, but if none of your tests win, you don't drive the business, right? You're not actually succeeding. So what we want to talk about is how you can craft good tests. It's important to know that we are already being hacked constantly. Facebook, Google, Instagram, YouTube, WhatsApp, just about any major video game you've ever played, they're all employing these kinds of concepts that try to tap into human motivations and drive desired results. The concepts behind what's driving this user behavior and understanding our thoughts and emotions are actually very well documented and understood. Today in this section, I'm going to be talking about Nir Eyal's book, Hooked, and on the subject of behavior design, BJ Fogg's book, Tiny Habits, The Small Changes That Change Everything. I suggest looking into those other books. There's other ones like Thinking Fast and Slow and Nudge that are also great. But I just want to get out there. These aren't my ideas. I'm just presenting to you what is already known in the space today. So this is BJ Fogg. He's a behavioral scientist. He serves as both the founder and director of Behavior Design Lab at Stanford University. And since the 90s, he's studied and proven that you can alter people's thoughts through the use of computers in highly predictable ways. In 2009, he published a concept that's become renowned across the world in both business and public health sectors for analyzing human behaviors and designing concepts to drive them. So, introducing the Fogg behavior model. So, he posits that human behavior B can occur. We need three things: M, motivation; A, ability, how something is easy or difficult it is to do; and T, a trigger. This is sometimes called a prompt, or P. You'll even see that later in these slides. So to get a B, you need sufficient M, A, and T. This model works for both offline and online. Getting any person, or in our case a user on our website, to perform a behavior requires these three things. Motivation. How much does the user have to do to perform the action? Fogg posits that it comes down to several factors, but basically that humans will seek pleasure and avoid pain, more or less. You don't want to think about the marketing tagline, you don't want to miss out on this. This is connecting the human desire for social acceptance and that they don't want to miss out. Ability, this is pretty straightforward in a lot of ways. How easy or difficult is an action to execute? Often you'll hear this described as friction in a website. If you make a user go through a lot of steps to accomplish a goal, you reduce the chance that the number of people are going to accomplish that goal, right? And prompt, or as Nir Eyal refers to it, a trigger. Prompts really inform the user what they need to do next. They inform the person exactly what steps need to be done. Click to play, press A to start, share this link on Twitter, etc. So if you have a design for an A/B test and the user is not performing the action that you think they should be, you can look to this model, evaluate your data, and try to determine where you're going wrong with your users. B equals M plus A plus D. Okay, so now that we've introduced what an A/B test is, and we've introduced the concept of how we can drive user behavior, let's discuss how to build a good test. There are 6 major tests to building an A/B test, or 6 major steps rather, I'm sorry. 1, you need to collect your data. So this is that up front. Analytics will provide insight into where you can begin optimizing. So you need to know what the users are doing in your application or on your website to even know what you want to test beyond, right? Next, identify goals. So this is what I was talking about before. Are you driving a conversion event? Are you trying to get a user to give you an email? Are you trying to get them to log in? Whatever that goal is, it needs to be identified and be looked at in the connection to the data that you've collected. 3, you want to form a hypothesis. So here's where we're taking what we learned before and we're saying, we think if we design our software in such a way, we'll elicit such a response, right? 4, create variations. So this is, you have your control version, the current version of your website, and you have the new version of your application that you want to get out there. You need to actually code the thing, right? This is the actual coding part. 5, run the experiment. So once you have your variations built and you're ready to launch your test, you launch it and you start gathering data. So users are now being assigned variations, getting experiences, and you're collecting that data. and then finally analyze the results. Oops, skip forward there a little bit. So let's design our A/B test. We're going to use our hypothetical from earlier. Let's say we're still working as developers at WidgetCo, and we've been asked to create a test for a credit card page that will help us to generate a percentage of increase in sales. First off, we need to consider what goal we're going to be trying to improve, and that means that's step 1 and step 2. Now, we can't use a qualitative goal, something like, I don't like the site because it looks old and out of date, or that font looks gross. Those aren't things that are very easy to measure, right? What we want to do is we want to look and say, oh, okay, so 8% of our customers that come to our credit card page actually never buy a widget from WidgetCo. Great, we can measure this. So if we decide that that'll be our goal, let's say we want to increase conversion rate by 20%, which would be a huge, huge swing. What does that mean? Well, if 100,000 people came to the page and 8,000 are currently buying, a 20% increase would be that on the average, we want to bump that number up to 9,600 customers. So that would be a goal that we're trying to set to see whether we can improve or not. In order to increase sales by 20%, that means we want to increase the likelihood of the B, and our B equals MA plus T plus P plus A, M plus A plus T in our model. So what we say is we suspect our customers are not motivated enough to get out their credit card to fill out our form, and that we feel we can make things easier to do. However, we think we can increase motivation. We decide we're going to add a timer. Lots of websites actually use timers. This taps into a sense of the clicking clock explains to reduce the price of widget is not only available for a limited time, but tapping into the human sense of urgency or missing out, right? Again, that social rejection. They don't want to miss out. So what's our new development process look like? So we brainstorm out the idea. That means we look at our data. We talk about the things that we want to do. We finally just come up with our goal that we think we can go after and how it should be built. But then, what do we need to do? What software can we use for launching our A/B tests? There are a lot of options out there. I'm not going to be talking about the statistical math and A/B tests because you can actually program this from scratch if you really wanted to. This information is easily found online. There's a lot of calculators for sample size, and you could create your own data persistence engine that would capture this data. The point is there's actually a lot of solutions out there. I highly recommend for those getting started to try to use Google Optimize. It's a first-class concept. It rolls well into other Google things, but there's lots of other popular examples. Optimizely is a world leader. It's also one that I've used extensively, both at JustAnswer and other companies. There is a cost to it, but it depends on the amount of traffic that you have on your website. So if you work at a high web scale, it's going to be more pricey for you. You might want to think about something else unless you really want to afford it. A/B Tasty is a great website for small starting companies. Their offerings are wide and very easy to understand, but there's also Adobe Target, SiteSpec, VWO, Quibbit, Sentient Ascend. There's a lot of different ones out there is the point. Well, what do most of these have in common? What are their similarities? Most of these A/B test engine options are what we call client-side injection vehicles. What that means is most of these website-based work by injecting all the code into the user's browsers and then activating the test code, which is usually JavaScript and CSS on the website context. They randomize the variations, and then the assigned code executes in the browser. This means that you're building your experiment on top of code that is being rendered by the user's browser, essentially, the HTML that the browser needs for rendering, and it's happening on top of there, whether you're moving elements or changing what it looks like, whatever. So how does the software work? Well, let's talk about how browsers work, right? So if I go and I land on what I call a SIP page at JustAnswer, it's one of our landing pages. Your browser receives the HTML, parses it, loads the CSS, parses the CSS, creates a DOM tree, and eventually, displays things. It takes HTML, goes into DOM parser, creates DOM objects. In the context of an A/B test, it's going to do that, but then when that browser test code executes, it's going to recreate the DOM tree, or in some instances, recreate the DOM tree and go through this whole process again. And so you can get a delayed reaction for customers. Some A/B tests can be noticeable. So when the user requests a web page from our servers, we return a web page. The user browser figures out how to display what to get it. And then the browser finishes figuring that out, and the code kicks in and tells the browser to change. The browser then repaints, and the user can access that page. There's not really a way around this fact. There's no possible fix for this flicker. You can either make your JavaScript test a blocking call in the head of the document, or you can put it into the footer, in which case that's what causes the flicker, because the page renders, that code loads asynchronously, the test code randomizes, finds it, and so you can get a noticeable effect. There's no hacks that our team can do if you're working in these environments. It's basically inherent to the system. And that's because client-side test code injection is a Kanye West interruption to the user experience. The browser requests Tay, but then ends up with Kanye. And the reality is, it's because it's just layers, right? As long as we serve layers, our tests are going to mean sending both versions to a browser, so there's additional page weight in these things, and asking them to render their tests on their side. You're basically pushing all the logic out to the client. So if it's so bad, why do we use client-side injection at all? Well, for minor changes, it's not that noticeable. So look at Taylor Swift's eyes and lips here. I'm just changing her eye color and her lips. That's not so bad. But it's when I want to do a major DOM change that this effect can be very noticeable for people. So let's talk about advanced alternatives. I'm going to discuss about an advanced A/B testing system that I helped build at my company. We call it Revisely 2.0, and that's because the first version was basically a client-side injection version. It was Optimizely, but just something that we ran internally, and we had a little bit more control over how that code ran. Our Revisely 2.0 system doesn't have the flicker. It gets rid of the need to code twice, and by that I mean if you write your code in JavaScript and your test wins, often you'll have to then take that and recode it into another way. There's no need for the browser to repaint because all experiences are held in cache, and you get one or the other. It was faster performing than our previous tests by whole seconds. Removes the concept of layers by only giving the user a single experience they want to see. And it worked on top of Google Analytics, which are tools we already used. What gave us the capability is an edge computing offering out there from Cloudflare, which is a CDN. That basically, they have 179 data centers internationally. And you can push your code to one, and basically it replicates across the world globally. So our A/B testing code is running very close to the client wherever they are on planet Earth. And if you don't know how a CDN works, it's just to minimize the distance between visitors. And I mean physical geographic distance between where a user is. So most of our servers at Just Answer are actually located in Chicago. So if you're out here in Ukraine and you have to call to Chicago, there's a second's worth of delay. Whereas if you can hit, a German cache server, obviously it's much faster from here. So many copies all over the world, right? So the basics of what we do, the client request comes into the Cloudflare CDN, machine closest to them on planet Earth. Our deployed code at that CDN location runs. So it's not running on the user's browser anymore. The experiment code is then basically a cookie reader writer and a router. So it looks to see whether you're eligible for an experiment based off a JSON rule set we deploy. Assigns it to the user, or writes a cookie in our case, and then serves the version from cache. The user just gets that and kind of goes down a route. Since the variation is already cached and it's returned without even coming back to our origin servers, it's super, super fast. The user just gets the test experience instantly. There's no flickers, no performance woes. So let's take a real look. So here on our control, we are loading our experiment on the client-side code rendering in the browser, and over here is what was coming from Revisely 2. And you can see that actually for an identical experience where there's nothing being changed other than just rendering the page, it was much faster in our cached version. And the part of the reason is speed of light sucks. So in that previous slide, my browser was in San Francisco, and I was making a call to Chicago, whereas in the other experiment, I was actually making a call to a San Francisco CDN, and I just got a cached version delivered directly to my browser. The trick is that we store all the variations, but we only serve one to the customer instead of serving all variations on top of each other. Okay, so how do we learn as an organization? After taking everything we learned, Just Answer launched a major test on our new platform. We came to the conclusion that if you're building and measuring well, but you don't learn across the org, you're not taking full effect of everything that's being done. So we make our learnings very public, well, internally public, not to the public. We hold special sets of meetings where all roles, engineering, UX, product, etc., can attend and learn what tests are succeeding and what tests failed. And when we capitalize on those learnings, I'll talk about what that meant for us doing a particular test next, but we look at the previous insights and then we try to share that knowledge across the organization so we can all keep getting better and better. So in Q3 of 2018, we wanted to create a new search engine marketing landing page. This was a radical new page design, full page hero imagery. It was making our chatbot the primary call to action because we wanted to increase the engagement with her. The page needed to be highly performant to maintain or improve upon our Google quality score, and we needed our page to be very configurable for different ad campaigns. So we needed high code portability. We wanted the different components in the page to be able to be switched out on the fly and yet still be highly cacheable. So our old SEM landing page kind of looked like this. It was kind of constrained. It had our chat UX over here and some other fields, but we felt like we were losing some increased engagement opportunity with our bot. So we moved things around and kind of made it just a right rail with some larger, higher definition imagery on the left. One of the things that we noticed is that if we did this same test as a client-side injection version, it took 8.5 seconds for the page load to happen. That's way out of bandwidth, right? So the test was losing when we tried to take a client-side approach, not because of the design was worse, but because it was just not as performant. So when we ran it as a Revisely 2, and it was actually faster than Control, we obviously saw much better performance. We immediately saw engagement go up, so more people were communicating with the bot and getting on to the next steps with the page. And then when we would look at a web page test, we noticed that the cache test variation was loading in less than a second load time. So you can kind of see here that the user is getting almost a fully painted page at 1 second, whereas client-side injection, we were nowhere in the ballpark yet. It also resulted in a 15% increase in conversion rate. So this goes back to what I was talking about in terms of our ultimate goal as software developers is to try to make the business improve. If we build the software and we write perfect code and the business fails, we're all out of a job, right? So one of the things we need to do is learn how to work differently. So let's go back to our new development process map as we had before. We brainstorm, we have an idea, but now we go through and we set our testing constraints. We figure out how our experiment needs to be designed, what is the sample size requirements, what do the variations look like, and we all get approval with basically an analytics group that we're going to build something that's going to be a good test. Then we actually code our experiment, we launch our experiment, we gather our data, we analyze our data, and then as a whole group, we work together to figure out if that won. And if it didn't, why didn't it win? And we try to come up with what we think will be a smarter version the next time. This is one of my favorite quotes from a software developer named Patrick McKenzie. It says, "Every great developer you know got there by solving problems they were unqualified to solve until they actually did it." Remember, quite often nobody has solved your problem before. Everything that we do is unique some of the time. And I started out saying at the beginning of this presentation that we're not typists but solvers of problems. So go forth, use these tools, and solve some business problems with A/B testing. Thank you so much for letting me talk with you all today, and now I'll take questions.